video we will be solving Sargodha University paper 2016, paper of Business Mathematics and Statistics for BCOM I. Let's move to the first question. Define any 10 from the following terms. So first term is statistics. Lot of time already discussed this question, that statistics is a subject of applied mathematics in which we collect, organize and analyze, interpretation and presentation of the data. It deals with all aspects of the data. Statistics is the science which deals the data after collection and organization of data. It is further analyzed statistically and interpreted. It is the science of average, counting and probability. Lot of other things are calculated in statistics, but normal definition is given here. Second question is variable. Variable is a quantity which variates or which differ from one digit to other digit. In contrast, there is a constant in which there is no variation. Third question is compound interest. Compound interest, as you know, that it is a concept of time value of money, in which only one single deposit or receipt is applied, and compound interest is interest calculated on the initial principal and also on the accumulated interest of previous periods of a deposit or loan. So compound interest can be thought of as interest on interest, and will make a deposit or loan grow at a faster rate than simple interest. In simple interest, interest is only calculated on the initial principal deposit at each time. So that is the main difference between simple and compound interest. So compound interest formula is also given here, and lot of time you saw in the previous videos that we calculated compound interest. Fourth one is discount. Discount is an offered amount less than par value. It may be offer both percentage, amount and quantity. In finance, discount refers to the condition of the price of a bond that is lower than par or face value. The discount equals the difference between the price paid for a security and the security's par value. The next question is primary data, most original, first and ungrouped data is called primary data, which is not statistically analyzed previously. The next question is sampling. In statistics, quality assurance and survey methodology, sampling is concerned with the selection of a subset of individuals from within a statistical population to estimate characteristics of the whole population. After that, probability. Probability is statistical measure to calculate the chance of occurrence or non-occurrence, or chance of happening something or not happening something. Probabilities answer always ranges from 0 to 1, both inclusive. It may be 0, it may be 1, or it may be between 0 and 1. The next one is attribute. Attribute refers to the quality of a characteristic. Qualitative variables are also considered as attributes. These are normally used in the qualitative analysis, like chi-square. So the theory of attributes deal with the qualitative type of characteristics that are calculated by using quantitative measurements. So the next one is null matrix. Null matrix is very simple to understand, that if all elements of the matrix are 0, then matrix will be called as null matrix. Linear equation, It is an equation which represents the linear regression model, and it describes the relationship between the given variable. The equation is given below. You can consider this, or you can say that y hat equals to alpha plus beta x, in which alpha is considered as an intercept and beta is considered as slope. Geometric mean is a type of average. There are a lot of different averages. For example, arithmetic mean, median, mode, geometric mean, harmonic mean. Geometric mean is a type of average which reduces the overestimation in the data which is due to time. So that is why geometric mean is mostly considered in the calculation of an index number. So it is a type of average. Formula for ungrouped data and grouped data are also given here. After that, null hypothesis. There are two types of statistical hypothesis. One is called null hypothesis and one is called an alternative hypothesis. Null hypothesis is denoted by H naught. Is usually the hypothesis that sample observation result purely from chance. So in alternative hypothesis is always denoted by H1 or HA. Is the hypothesis that sample observation are influenced by some non-random cause. So normally in chi-square table or in chi-square calculation of qualitative analysis, we assume no relationship in null hypothesis and relationship in alternative hypothesis. After that, now we move to the section 1, question number 2, part A, that calculate the mean, median and mode from the following data. Data is given here. We want to calculate median and mode also, so we need the class boundaries. So as you are seeing here, that upper limit of first class and lower limit of second class is not equal. So first of all, take the class boundary. How can we take the class boundary? Simply subtract these two values, 10.3 minus 10.2 divided by 2, and what comes should be subtracted from the left side and added to the right side. I think 10.3 minus 10.2 divided by 2 equals to 0.05, and when 9.8 minus 0.05, it will be equals to 9.75. So right, 0.05. So 0.05 is subtracted from the left side and added to the right side. So 9.8 minus 0.05, 9.75, and 10.2 plus 0.05 equals to 10.25. Similarly, 10.3 minus 0.05, 10.25, and 10.7 plus 0.05 equals to 10.75, and so on. After that, second important thing, in all videos I recommend that first of all calculate these three things: class boundaries, class mark, and cumulative frequencies. So next thing which is to calculate is the class mark. Simply add up these two class boundaries and divide the result by 2. So 10.25 plus 9.75 divided by 2 equals to 10. And after that, what is the difference? Difference is 0.5. So just add up 0.5 in next value. So 10 plus 0.5 equals to 10.5, 10.5 plus 0.5 equals to 11, and so on. After that, cumulative frequency, take first frequency here 7 and add up the next frequency into the previous total. So 7 plus 12 19, 19 plus 17 36, 36 plus 14 50, and so on. If last cumulative frequency is equals to the sum of f, then your calculated cumulative frequencies are okay. So now we move to the formulas. Arithmetic mean is equals to sum of fx divided by sum of f. So what is fx? Fx is simply the product of f multiplied by x, and take the sum, 6 divided by 60 equals to 11.1. Median, in case of median, first of all select the class boundary, select the model class. How can we select the model class? Simply calculate this n by 2. N is equals to sum of f, so 60 by 2 equals to 30. 30 falls in the cumulative frequency of 36, so that will be your model class. So L will be lower class boundary, 10.75, plus H is the difference of x values, which is 0.5. F is the frequency in front of model class, 17, and n by 2 is simply 60 by 2, we already calculated, that is 30, and minus C. So C, what is C? C cumulative frequency, which is the cumulative frequency before the cumulative frequency of model class, so that is 19. So after solving this, median will be 11.07. Now we move to the mode. First of all, you must select the model class for mode. And what is the process to select the model class for mode? Simply the maximum frequency, which class which has maximum frequency is the model class for mode. So in this class you will solve mode. So L is 10.75, FM or maximum frequency is 17, F1 is 12, and F2 is 14. And multiply by H, that is already we learned that H is the difference of x value, so that is 0.5. So after solving this, mode will be 11.06. Now we move to the part B, that mean and variances for two players runs obtained are given below. Mean for first player is 28.74 and mean for second player is 20.5. So variance for first player is 79.39 and variance for second player is 54.76. Which of the player is more consistent in his performance? If this type of question is already discussed in, I think, in some previous paper, but once again we will see this question, that if we take the decision on the basis of average, then as you are seeing that it is clear that mean of player A is greater than the means score of player B. So on the basis of average we can select player A, but hold on, here is the measure of dispersion, and that is variance. Variance is very important measure of dispersion, or we can say measure of risk. So the more the variance, the more will be risk. So as you are seeing here that player A on the basis of average is okay, but on the basis of variance his variance is too much, 79.39, as compared to the variance of player B, 54.76. So on the basis of variance we should change our consideration and we will choose player A, because to select player A is risky. Why this variance is too much high? Because there is a lot of variation in his scores, and the variance is low for player B. It means that it is more a consistent player than player A. So we should choose player B. After that, question number 3, part A, consider the following data. We lot of time already calculated this question. Which type of index number is asked that prove that Fisher ideal index number is the geometric mean of Laspers and Passes index, and in B part or second part also calculate Marshall Edgeworth index number 1980, taking 1980 as base and 1985 as current. So price of base here and quantity of base here is considered as P naught Q naught, and price and quantity of current time period is considered as P1 Q1. So we need 4 calculations: P0 Q0, P1 Q0, P1 Q1 and P0 Q1 calculations are given here. You can see that sum of P0 Q0 is the simply multiplication of these two, and P1 Q0 is the multiplication of this one with this one, and P1 Q1 is the multiplication of these two, and P0 Q1 is the multiplication of this one with this one. And after the multiplication one by one, the sum is sum of P0 Q0 8950, sum of P1 Q0 9020, sum of P1 Q1 10274, and sum of P0 Q1 10260. After that, we just put up the values into the formulas. Less pairs, sum of P1 Q0 divided by sum of P0 Q0 multiplied by 100, and answer is 100.7821. Pastures indexes, sum of P1 Q0 divided by sum of P0 Q1 multiplied by 100, and the answer is 100.1364. And now we come to the Fisher's ideal index, which is the geometric mean for the less pairs and pastures. Less pairs index multiplied by pastures index under root and multiply by 100, and answer is finally equals to 100.4576. So it is proved that Fisher ideal index number is the geometric mean of less pairs and pastures index number. After that, Marshall-Edgeworth, we simply add up less pairs index with pastures index and take the result multiply by 100, and the answer will be 100.4372. After that, B part of this question, calculate chain index number from the following data. So here frequency is given 5, 6, 8, 7, 9, 10, 12, 11, 13, 15, and years are 1990 from 1990 to 1999. So it is a simple index number in which only one frequency or one product frequency is given, so it is a type of simple index number. So in simple index number, we are going to calculate the chain index. So in chain index, we calculate chain index in simple index with the help of two different steps. First of all, we will calculate the link relative. So what is the formula for link relative? Simply Pn divided by Pn minus 1 multiplied by 100. Here it is Pn minus 1. So Pn stands for current price and Pn minus 1 stands for previous time period price multiplied by 100. So for 1990, current price is 5 and we don't have previous time period price in the first year. So we consider same 5 as Pn minus 1 multiplied by 100, and this will be equals to 100. And similarly, chain index is also considered as 100 because chain index is equals to previous chain multiplied by current link relative divided by 100. So we don't have previous chain in the first year, so we should consider chain index as 100 for first time period. After that, we will calculate Pn is 6 and Pn minus 1 previous time period price 5 multiplied by 100 120. For 1992, Pn is 8, Pn minus 1 is 6 multiplied by 100 is 133.34. For 1993, current price is 7, previous time period price is 8 multiplied by 100 87.5, and so on. And chain index, previous chain multiplied by current link relative divided by 100. So for 1991, previous chain is 100, current link relative is 120 divided by 100 equals to 120. And for 1992, previous chain is 120 multiplied by current link relative 133.34 divided by 100 equals to 160.008, and so on. Question number 4, part A. A bag contains 4 red and 6 green balls. 3 balls are drawn. Find the probability of drawing 2 red and 1 green ball. Number 2, all are red balls, and number 3, no red ball. Here we will apply the combination method. Because draw is more than 1, 3 balls are drawn. So if draw is more than 1 and if there are different categories, then we should apply the combination method of probability. So what is that method? So simply first take the sum. Bag contains 4 red, 6 green, 6 green. So uppercase n will be 6 plus 4 equals to 10. Now what is draw? Draw is considered as r, lowercase r equals to 3. First of all, we will calculate the sample space. Lot of time this type of sample space is calculated in the case of sampling without replacement. So NCR or combination method, after putting these values 10C3, and you can very easily calculate this through any calculator. So the result will be 120. So there are 120 different possibilities of drawing 3 balls in the variety. Now we come to the events. Events are the question, those are asked in the question. So 2 red and 1 green ball. So what is the number of red balls? 4 red, so we place 4 here. Number 2, 6 green, so we place 6. And now consider the question, 2 red and 1 green ball. Place 2 below red and place 1 below green and calculate the combination. So 6 multiplied by 6 equals to 36. After that, what is the second part? All are red balls. So place red and place the total of green. And if all red balls, so what we are drawing? We draw 3 balls. So 3 are placed below red balls and there is no ball left. So 0 will be placed below green balls. So 4 multiplied by 1 equals to 4. After that, what is the third question? No red ball. If there is no red ball, so place 0 below red balls and place 3. If there is no red ball, then absolutely these 3 are green balls. So place 3 below the green balls and calculate the combination, and combination is 20. So these are 3 events, 36, 4 and 20. After that, to calculate probability, it is very easy. That probability is always equals to event divided by sample space, that is sample space, and that these are 3 different events. So first probability, 2 red and 1 green ball should be equals to 36 divided by 120. Second probability, all our red balls should be equals to 4 divided by 120. And third one, no red ball should be equals to 20 divided by 120. So answers are given here. We move to the second part of this question, that let x be a random variable with a probability distribution as follows. So if x is 1, 2, 3, 4, 5 and their relative frequency is 0.125, 0.45, 0.25, 0.05 and 0.125. The probability of x is given here. Calculate E of x. E of x, what is the meaning of E of x? E of x is equals to mean. And second one is the variance of x. So what is equals to mean in probability distribution function? It is always equals to sum of x p of x, or you can say x f of x. So x p of x, simply multiply this one with this one by one. So xpx 0.125 multiplied by 1, 0.125, 0.45 multiplied by 2, 0.9, and after taking the sum is 2.6, and that is mean, because E of x equals to sum of xp of x, which is equals to 2.6. And after that, variance. Variance is very simple. That's first of all we take the square, sum of x square p of x, and x square p of x. We lot of time this type of calculation we used in the calculation of standard deviation and variance, where we took the square of fx square, and normally I told you lot of time that fx square is equals to fx multiplied by x. So what is x square p of x? Simply it is equals to x square x p of x multiplied by x. That should be equals to x square p of x. So 0.125 multiplied by 1 equals to 0.125, 0.9 multiplied by 2, 1.8, 0.75 multiplied by 3, 2.25, and so on. So x square p of x is 8.1 minus mean square or sum of x p of x whole square. So after putting the values into the formula, variance should be 1.34. Question number 5, part A. A population consists of 3, 7, 11, 15, 19 numbers. Take all possible samples of size 2 without replacement. Construct sampling distribution of means and calculate mean and variance of the distribution. So first of all, population is 3, 7, 11, 15, 19. So uppercase n should be 5. 1, 2, 3, 4 and 5. And sample size is 2. So lowercase n will be 2. In without replacement case, all possible samples are calculated through combination method. So NCN 5C2 equals to 10. And what are these 10 samples? So 3, 7, 3, 11, 3, 15, 3, 19. After that 7, 11, 7, 15, 7, 19. 11, 15, 11, 19 and 15, 19. So these are the samples. Take the sum of these samples and take the individual means of these samples. 7 plus 3, 10 and 10 divided by 2 because there are two values. So 10 divided by 2 equals to 5, 11 plus 3, 14, 14 divided by 2, 7 and so on. After that we will calculate the frequency distribution of these means. So least value of 5, after 5 there is 7, after that there is 9, after that there is 11, 13, 15 and 17. So these are placed here, and after that we will count the frequency of each item. So 5 is appeared one time here, 7 appeared one time here, 9 appeared two time here, after that 11 appeared two times, so frequency will be 2, 13 appeared two time, 15 one time and 17 one time. So these are the frequencies. Now we need two more calculations, fx bar and fx bar square. Fx bar is simply the f multiplied by x bar, and fx bar square is equals to fx bar multiplied by x bar. So sum is 1330, 110, 10. So simply put these sums into the formula for mean, for sample statistic. Mu x bar equals to sum of fx bar over sum of f, 110 by 10 equals to 11. Variance, sum of fx bar square over sum of f minus mean square, and the variance is equals to 12. And now we come to the here it is construct sampling distribution of means. Okay, we construct this distribution and calculate mean and variance of the distribution. Okay, question is complete. So B part, calculate the value of chi-square from the following contingency table. So there are 2 rows and 3 columns. So 2 variables, breed and yield. Under breed there are 2 sections, red and white. Under yield there are 3 sections, high, medium and low, and we want to check the association between these two through chi-square. So first of all, if total is not given in the question, you must take the total as total are calculated here. After that, first step is to take the hypothesis. Under null hypothesis H0, we consider that there is no relationship between these two variables, and in alternative hypothesis we consider that there is association between these two variables. Step number 2, level of significance, which is I think given in the question. Okay, so step number 2 is the level of significance. If it is not given, normally level of significance which is taken is 0.05 or 5% level of significance. Third thing is test statistic. So test statistic is simply the formula for chi-square, which is equals to sum of observed frequency minus expected frequency square divided by expected frequency. That is the formula for chi-square. And step number 4, calculation of expected frequencies. Because observed frequencies are given here, these are observed frequencies excluding total. Excluding total, there are 6 observed frequencies: 46, 29, 28, 27, 14 and 6. And we need expected frequency for each observed frequency. For example, if we want to calculate the expected frequency for 46, so how can we calculate? Row total multiply by column total divided by subtotal. So 103 multiply by 73 divided by 150, as you are seeing here, 50.127. So for observed frequency 46, expected frequency will be 50.127. After that, for observed frequency 29, expected frequency will be equals to row total 103 multiplied by column total 43 divided by subtotal 150, as you are seeing here. So 29 observed frequency, and for this observed frequency, expected frequency will be 29.527 and so on. You can pause the video and see all the calculations. So expected frequencies are calculated. After that, we will calculate finally chi-square. So place all observed frequencies 46, 29, 28, 27, 14, 6 here, and in front of each observed frequency, relevant expected frequency is placed in front of observed frequency. So 50.127, 29.527, 23.346, 22.873, 13.473 and 10.654 will be placed here. And after that, just take the subtraction of these two. After that, take the square, and each result will be divided by each expected frequency. So 17.032129 divided by 50.127 equals to this one. Similarly, this one divided by this one equals to this one, and so on. And take the sum of all these, that is 4.075220744. Step number 6 is to take the critical region. A lot of time I defined that only two things we need, that one is degree of freedom and second one is level of significance. For level of significance 0.05, the degree of freedom row minus 1 multiplied by column minus 1. So there are 3 columns excluding total and 2 rows. So 2 minus 1 multiplied by 3 minus 1. So 2 minus 1 multiplied by 3 minus 1, which is equals to 2. So under 2 degree of freedom, go to the chi-square table. Under 2 degree of freedom, 0.05 level of significance, tabulated value will be 5.99. So what is the critical region? If our calculated value exceeds the tabulated value, then it is considered as to critical region. So our calculated value 4.07 is less than our tabulated value, so it falls in the acceptance region, not critical. So if our calculated value falls in the acceptance region, or we can say if it is less than or equals to the tabulated value, then we accept null hypothesis and reject alternative hypothesis. So conclusion is that the calculated value of chi-square is 4.07 is less than the tabulated value of chi-square 5.99, or 4.07 falls in the acceptance region, so we accept the null hypothesis, and we can say that there is no association between breed and yield. Question number 6, part A. Solve the following equation for x 1 by 3 multiplied by x by 4 minus 3 plus 5x by 6 minus 5x by 4 equals to x minus 12 by 5 minus x plus 3 by 3. So first of all, in first section, simply simplify this. X should be multiplied by this and this one, and this 3 will be multiplied by 1, so minus 3 by 3 should be equals to minus 1. And after the simplification here, we will take the LCM, and further it should be simplified that 12 tens are 120 and 10 multiplied by x should be equals to 10x, and 6 20s are 120, so 20 multiplied by 5x should be equals to 100x, and so on. And after the simplification, it will be equals to 150x minus 174x equals to 120 equals to minus 12 by 5, and further it will be equals to minus 24x by 120 equals to minus 12 by 5, and simply x by 5 is equals to 12 by 5, and 5x will be equals to 60, and x will be equals to 60 divided by 5, that will be 12. Okay, right. Minus on both sides will be cancelled with each other, so 24x by 120 and 12 by 5, and 24 ones are 24 and 24 fives are 120. Okay, so now come to the B part. Solve the following equation by quadratic formula. X square minus 10x plus 24. Very simple it is, that A should be 1, B should be minus 10, and C should be 24. Just simply apply the quadratic formula and put all these values into this formula. So one x is 6 and another x is 4. So solution set for x is 6 and 4. Question number 7 part A. Solve the following linear equation by matrix approach. 2x1 minus 3x2 equals to 5. So 5x1 plus x2 equals to 4. So these are two equations. Here instead of y, x2 is taken. So one variable is x1 and another variable is x2. So first of all, convert it to the matrix form. So 2 minus 3 5 and 1. 2 minus 3 5 and 1. What are the variables? X1 and x2, and third matrix should be 5 and 4. So we need here, under Cramer rule, we need here three different determinants: determinant of A, determinant of x, and determinant of y. Because x is equals to a x determinant divided by a determinant, and y equals to a y determinant divided by a determinant. So a determinant is simply 2 multiplied by 1 minus 3 multiplied by 5 equals to 17. Now take this column from here, place here, and take the determinant. So here 5 multiplied by 1 minus 3 multiplied by 4, which is equals to 17. And after that, take this column from here and place here and take the determinant. So 2 multiplied by 4 minus 5 multiplied by 5 is also equals to minus 17. So now put all these values into these two formulas. So for x, ax1 determinant divided by a determinant equals to 17 by 17 equals to 1, and for x2, ax2 determinant divided by a determinant, answer is minus 1. B part, if A is 0, minus 2, 3, 2, 0, 4, minus 3, minus 4, 0, prove that A transpose is equals to A inverse, also identity matrix. So first of all, we take the transpose. Transpose is just be changing the order of the matrix. So here 0, minus 2 and 3 is written in the row form. When we convert it to the column form, 0, minus 2, 3, 2, 0, 4 in the form of row, convert into the row column 2, 0, 4, minus 3, minus 4, 0 is in the form of row, converted to the column minus 3, minus 4, 0, and take the determinant. because determinant is needed to calculate the A inverse. A inverse is equals to adjoint of A divided by A determinant. I prefer that you must calculate A determinant first, because if A determinant is 0, it cannot be further calculated, because A inverse is equals to adjoint divided by determinant. So if determinant is 0, then all the matrix is 0. So first of all calculate determinant, so take 0 and exclude the row and column in which 0 is. So this row and this column will be excluded, and what is the remaining? 0, 4, minus 4 and 0. So 0 multiplied by 0 and 4 multiplied, there is no need to calculate this, because when it multiplied with 0 it will also be 0. So let's take to the next step. After that, place the minus sign and take this minus 2 here, and the column and row will be excluded from this. So remaining values are 2, 4, minus 3 and 0. So 2 multiplied by 0 minus 4 multiplied by minus 3 as it is given here, plus 3 will be placed here, and after that exclude the column and row in which 3 is. So what are the remaining values? 2, 0, minus 3 and minus 4. So 2 multiplied by minus 4 minus 0 multiplied by minus 3 as these are given here. So 0 minus 2, 2 multiplied by 0, 0, minus 3 multiplied by 4, minus 12, plus 3, 2 multiplied by minus 4 is equals to minus 8 and minus 0. So after calculation this minus and minus will become plus, and plus 12 multiplied by minus 2, after that plus 3 multiply with minus 8, and this will become 0. Question number 8, part A, that if rupees 200 are invested at each year, so it is the case of annuity, because there are multiple payments invested each year at 5% interest compounded annually. What would be the total amount of investment after 100 years? So n will be 100, and rate of interest is 5% compounded annually, so interest will be 0.05, and after that if rupees 200 are invested at the each year, so R will be 200, and at each year at 5% compounded annually, what would be the total? So future value is asked in this question to calculate. Okay, there is no indication here in the question, either it is a case of ordinary annuity or annuity due. In ordinary annuity, each payment stream is received or invested or deposited at the end of the time period, and in case of annuity due, each payment stream or receipt stream is received or paid or deposited at the beginning of the time period. So there is no mention, there is no indication about these two, either it is a case of ordinary annuity or annuity due. But we are assuming that it is a case of annuity due, because lot of time we calculated ordinary annuity future value. So in this question I am considering this, that in this question we will calculate annuity due method, future value under annuity due method. So what is the formula? R multiplied by 1 plus I raised to power n minus 1 divided by I multiplied by 1 plus I. Only this part of the formula is the formula for future value of ordinary annuity, and if we multiply only 1 plus I with this, it will become annuity due. So after putting these all values into the formula, and after solving, future value will be 548105.25. Part B, that find the sum of the series 3 by 2 plus 1 by 3 plus 1 by 6 up to 10 terms. So 10 terms, alpha 10 will be equals to 2 by 3 plus 1 by 3 plus 1 by 6. Apply rule. What is the rule? A by C plus minus B by C equals to A plus minus B divided by C. So 2 by 3 plus 1 by 3 equals to 2 plus 1 by 3. Finally, it will be equals to 3 by 3 equals to 1 by 6, and 3 by 3 equals to 1 and 1 by 6. So 1 plus 1 by 6 equals to 7 by 6. So thank you very much. Stay safe, stay blessed, take care of yourself, your respondents, your loved ones, and take care of the persons around you. Once again, thank you very much. I will come with another paper soon.